Thanks, everyone, and thanks for allowing me to come here and give this talk today, Florian. Thanks for the guys at AWS for hosting us. Really appreciate it. Really great to have this space. I tend to talk fast when I'm excited about something, so if you want me to slow down or if something doesn't make sense, then just like raise your hand or yell slow down or ask a question. That's totally cool. Okay. 천천히 말해볼게요. Okay. Okay. So write once, run everywhere. We've all heard this this promise from development tools before. Whether it's been like Java, that was a thing back from the 90s until well, I mean, hey, it's still, you get this prompt like 6 billion devices run Java or something like that every time you install it on a new computer. C has often been hailed from the past as an example of something that's portable. You write your code and you run it everywhere. Although if you've written C, then you probably know that's it's only true to a certain extent. There are some parts of C that are portable and then others that aren't. And then in the mobile space, we have React Native, where the idea is that you write all of your app code and UI in JavaScript. And then more recently, Flutter from Google, where they invented their own new programming language, Dart, that is the same kind of process where you're trying to combine the code for the logic and the UI all in one thing, and then you can run it everywhere. Why do people want to do this? The short answer is that we have limited resources. There's only so many developers to go around. Developers are expensive, particularly native mobile developers. You can't necessarily go and hire a new iOS developer and a new Android developer in order to build some kinds of projects. But when you do this, you make some trade-offs. If you've ever used something like React Native or Flutter before, you probably know that in Flutter, maybe the UI is going to feel like a bit too googly on your iPhone. Or in React Native, then, well, you have to write everything in JavaScript now, and you can do some things to get down to the new Apple functionality, like say you want to integrate StoreKit. You have to then write some Swift code and some bridge or download a component that does that. Even to get the location in a React Native app, you have to use some kind of like go npm install something and then use that to get the device's location. But there is some value to this. Being able to have your business logic, the core of what makes your app, this is something that you can write in a way where it runs everywhere. And similarly, your models for your data are not really going to change no matter where you're running it. These are two things that you can extract with relatively little compromise. There are some trade-offs that you have to make, but these two things you can extract in a relatively straightforward way. And the important thing is it doesn't impact the user experience of your app. Your users are still going to get a full native app. And that is the interesting thing that we're going to talk about today. But first, a little bit about me. I built my first iOS app in 2008. I've been an independent developer for about 10 years after that. And then since 2017, I've been running my own startup, which I'll talk about in a second. I've been coding since I was a little kid. But my first real app was this iPhone app in 2008 because Apple had just launched the iPhone and the iPod Touch, and they were giving away iPod Touches to everyone who bought a Mac for school. So I got one of these for free, and then I realized that there was a problem because my campus network required a login after 15 minutes of inactivity. They wanted to monitor everyone's network connections. So if you used the iPhone back in the day, there was no password manager, there was no 1Password, there was no iCloud keychain. iCloud didn't exist. You didn't even have copy and paste, actually. So I just made a simple app that would store your username and password, and all that it did was it would store it, and when you opened the app, it would try to log you in, and if it was successful, it would quit. So yeah, then everyone on campus bought the app. Really lucky timing. Was an independent developer for about 10 years, and then since about 2018, I've been doing a lot of stuff in Rust. Fun fact about me, I guess, hey, I didn't even remember the icebreaker thing, but I guess I've got an icebreaker slide here. Fun fact about me, I've actually earned more money consulting companies to do React Native upgrades than I have actually spent writing the React Native app functionality, because I can see some people nodding their heads and smiling, because the process is just so bad, the developer experience of having to spend like 3 days to just do a minor version upgrade. And this is really bad developer experience. And so I was like, there's got to be something better. What can we do? And so yeah, that's what we'll talk about today. My company, Stadia Maps, we started in 2017, right before I came to Korea. We do maps for business apps. So we're not aiming to replace Apple or Google in the sense of a consumer app that you pull up and get directions to the center field. We're trying to build apps for businesses who need location functionality. That could be maps, routing, or search are our three kind of main things. Maps, you can call an API and get like a PNG or JPEG image. You can get vector tiles, and then you can put these either in MapKit or in a SDK like MapLibre, and you can render interactive map experiences. Routing, you can get directions between places. You send an API request with latitude, longitude of the starting point, some places that you want to visit, and how you want to get there. Like say, I'm walking, or I'm driving a car, or I'm driving a golf cart. Ask me about that after if you're interested. And then search, because people want to know, how do I get to center field, or how do I get to Gangnam Station? Turning this information, this plain text into a geographic location. That's another thing that we can do via API, so autocomplete as you type and things like that. So turn-by-turn navigation is actually what first motivated me to look into the Swift and Rust interoperability. We offer the routing API, and it serves some use cases that Apple and Google can't fulfill, like golf cart directions. And understandably, our customers wanted to put this into an app. But there isn't like a popular open source SDK that's modern that you can just go drop into a Swift UI app in order to build this kind of thing. So I made it my side project for about a year to build that. And we ended up building the core of it in Rust, and you can see a screenshot here, and maybe afterwards I'll give it a quick demo as well. But yeah, this kind of, what goes into a navigation app? You have a bunch of like state that goes into your Swift UI screen. So if we go back and look at the screenshot here, we can see a little puck at the bottom showing where the user is. We can see what the name of the current road is. We can see the speed limit. We can see how far it is until the next turn, how far until we arrive. There's also some stuff you don't see on the screen, like is the user off the route? Did they miss a turn? These kinds of things. How do we model all this? A first attempt in like your Swift UI app might be to have a struct. And it could look something like this. You have the user's location, you have a route, and you have some properties for different things, and then you can kind of translate that into your Swift UI state objects. But there's a couple of problems here. Like, what if the route is null, but is navigating is true? There's all kinds of ways when you model data like this that it just doesn't really, doesn't make any sense. And so how do you do that in your app UI? So in Swift, the creators drew really heavily on the work of the functional programming community, which, among other things, is really good at reducing everything to a problem of how do you represent this in types. And my favorite type data structure is the enum, because there are so many ways you can use it to make illegal states, things like you have a null route, but your state says that you're navigating in a Boolean field. That just doesn't make any sense. So we can remodel that as an enumeration. And Swift has really first-class support for this, and not very many languages do. Like in JavaScript, you can't do this. So here's a much better version of this. We have at the bottom, we have our trip state, which is we're either navigating or the trip is complete. inside there, we can have associated data with it because Swift lets you have associated data inside enums. And then inside there, then we can have all this other information like what's the user's current location? Is there a route? Are they on the route? Are they off the route? If they're off the route, how much are they off by? And we can model this really, really cleanly in enums. And you just can't do this in JavaScript. The second thing that we'd like to share across so that's data, our data models. The second thing that we'd like to share across apps on different platforms is business logic. Here are a couple of examples of business logic that you would have in a navigation application. You would have things like distance calculations. How long is this sequence of points in meters? Is the user off the route? And we'll look at some interesting examples of how we can do that. Snapping the user's current position to the route line. When you're driving a car in Gangnam, then you're going to have a whole lot of GPS noise, signals reflecting off of buildings and stuff, and so your car is going to be like kind of going all over the place if you don't have this kind of snapping behavior. So this is all stuff that is just core business logic. It doesn't need to be implemented both in Swift and Kotlin if you're doing a multi-platform app. And so just like we made it easier to reason about state with enums, pure functions let us do the same thing for the core business logic of our application. Pure function basically just means something that doesn't have any like external dependencies like global variables. So a function that returns a random number is not a pure function. Whereas if for every time for every input to a function, say a function that takes one argument, it always returns the same value, that is a pure function. And these are really nice because then we know that there is no external dependency, say in your Swift code, that is changing what's going on in the core of your app. You know exactly what you're passing in is the only thing that determines what comes out. So in the case of navigation, you can think about the whole process as a finite state machine. I'm starting off at this state. I am going from here to Gangnam Station. I have a list of GPS coordinates that I'm expected to proceed through. I've organized those into steps. And the only thing that can change is when I do some operation and say, what is my next state after this? That's going to look like in an iPhone application, a GPS update coming in this case. So when I get a GPS update, I'm going to figure out what is the next state that I want to be at, and then it's just this very reproducible thing, and it makes it really easy to reason about. And it also makes it so that you have this clear boundary between the core business logic of your app and the front end side of things. So what languages could we use to do something like this? C++ is probably the historical favorite. Most large companies today, like Meta, AWS, I know that they all have a lot of C++ in their mobile SDKs, and this is what they usually use to ship the core of their business logic. Kotlin is also gaining popularity with Kotlin multi-platform. It's an interesting hybrid between like the React Native model or Flutter model, where everything is all in one, the UI, the business logic, and everything is all wrapped together. Kotlin multi-platform, though, is now starting to support the use case of libraries, which was something that it didn't support like a year ago. So there's becoming actually increasingly more options, which is a really good thing. And then there's my favorite, Rust. Rust is cool because it compiles down to native code. There's no intermediate runtime that you have to have like JavaScript. It's type safe. Also, unlike JavaScript, where when you add numbers to strings, you get interesting results, and if you subtract numbers from strings, you get more interesting results. If you've seen the WAT video, I should show that later. Yeah, JavaScript. It's also memory safe, unlike C++. In a language like C++, if you like dereference a null pointer, then you get this like seg fault and your whole app crashes. in Rust, and Swift as well. It's technically possible to do this by calling out into like unsafe code, but your safe Rust or your safe Swift code is not normally going to do this. And it's also portable, not portabile, as I spelled on the slide. And the portability part's really interesting. So I was talking earlier about C. C is, we say it's portable, meaning that you're not writing like Intel x86 assembly or ARM v7 assembly. Yeah, it's portable in that sense, but can you always just take some C program and run it on another computer? Actually, most of the time the answer is no, unless you're just not using anything interesting at all. Rust, actually, most of the time the answer is yes. And it even extends to the web platform, which is really interesting. I'm not sure how many of you have heard of WebAssembly, but it's like the world's worst named technology, but it's super, super duper cool. It's similar to the promise of what Java was trying to do with their platform independent bytecode. But yeah, anyways, Rust actually does pretty much deliver on this promise. You can just cargo, or you can just like Rust up, add a new tool chain, and boom, you now have a iOS cross compiler right on your laptop, and it works really, really well. Okay, so how would we actually design a thing like this? Because, like I said at the beginning, we're not using something like Flutter or React Native. So how are we going? Like, what's the framework? How do we figure out a way to share these data models and business logic? So I apologize for my really, really terrible graphic design skills, but I hope this is a useful diagram. The way that we've architected this navigation SDK, and we've published a template on GitHub as well for anyone who wants to kind of copy this model. We have at the very core in the middle is our business logic. That's the only thing that's written in Rust. And this is dealing entirely in pure functions. What you pass in determines what gets returned out. There's no random generator or something like that. There's no reaching back into Swift asking for global variables or anything like that. And in the core, we have things like our data models, spatial algorithms like snapping the user's current location to the route line. We have simulation, so we can take a route from the API and we can generate a series of location updates off of that. And like this is shared code. This is the kind of thing that you want to put in your unit tests to verify that that you don't have some regression or whatever. Say you are incorrectly detecting when the user should move to the next step. We can actually write a regression test against this because everything is entirely in pure functions, and that's another cool property of those. Then this magenta layer in the middle, the bindings layer, that is code that we don't have to write because a really awesome tool from Mozilla called Unify does all that for us. That basically adds a light translation layer in between your Rust code and Swift or Kotlin, or I think they even support Ruby. It's very interesting. They support React Native as well, which is also pretty cool. So yeah, you can write your entire business logic in Rust. Then you have these bindings that are generated, and then that's in between you and the platform layer, which is your Swift code. So from Swift, then you can access all the iOS native device features. You can access location services. You can write your UI in Swift UI or Jetpack Compose. Heck, you could probably use what's it called? Kotlin multi-platform compose. Yeah, you can do everything that you would want to do in your normal iOS app. You have your native UX, and the only thing that is that's in the core is the shared business logic, and then your data models, which you now no longer have to copy and paste from iOS to Android. So normally, if you're writing some kind of business application, you have your database or something like that. You would have to write all that twice, once in Swift, once in Kotlin. You don't have to do that anymore with this architecture. Anyone have any questions so far, real quick, by the way? Free to interrupt.
I have.
Yeah, go for it, Clement.
So what if you wanted to also share networking?
Yeah. Oh, that's a good one. Yeah.
I can see
Yeah.
the functional core.
Yeah.
In our case, for example, actually the networking and a
Yeah.
lot of those platform libraries,
Yeah.
they would be way bigger than the functional core.
Mm-hmm.
So I just wonder if there's a way to
Yes.
some of it share the networking part.
Yeah, there is. So you can't get around the need to use, like, say, URL session on iOS. But what you can do is you can have all the request generation part of it happen and all the like deserialization happen in your core, and you can have that logic shared. So that's actually exactly what we do here. We have a REST API that you send some information to saying, these are the coordinates that I want, directions between, and all that. And what we've done in the Swift layer is we just have a really nice high level Swift interface. Then it calls the core, and then it returns an object that has the raw HTTP body, the method, get or post, and I think that's it. And yeah, query string parameters. So yeah, you just reduce your request to something that can be passed across that boundary, and then URL session makes the request, and then when it comes back, then it passes it back into the core to decode it. So all that logic is shared. Yeah.
Platform library, that
Yeah.
is the Rust framework. That means that is
Platform library is iOS.
iOS.
Yeah.
That means where is the Rust framework? Where theory?
That's in the middle, the blue section, functional
blue
core.
section.
Yeah. Yeah.
The
It's a bit small. Sorry about that. Yeah. Should have made Ferris bigger. Yeah.
Okay, the Rust framework.
Yeah.
And outside, that is Swift to those things outside.
Yeah. Yeah. So in the middle, you would write your Rust logic, like say generate a HTTP request body.
That means Rust framework belongs to Swift UI framework.
Yes, we'll talk a little bit about that. Yeah. Yeah, we'll talk about that a little bit in the packaging side as well. So it's a Swift package using a SPM package, and then there is a binary XC framework that includes your Rust in the middle. Yeah. Yep. Yeah. Yeah. I'll talk about how all that works in a little bit here. Good question. Anyone else before I go on?
I have more, but I'll ask.
Okay. Cool. Okay, so let's talk about that blue section in the middle of the core. Don't worry if you're not familiar with Rust. I'm going to keep everything at a super high level. So first, let's look at how data models work. This one is for a single step in a longer route. We have some properties like the geometry. Vec just means like a array in Swift. So it'd be like the square brackets. Option is like optional in Swift already. F64 is like double 64-bit floating point. Yeah. So we have a couple of properties here. It's mostly a normal struct, but we also have this stuff at the top. This is similar to like an attribute in Swift or a decorator in Python if you use that. So this derive unify record thing. What's that do? That basically says, hey, nice framework that Mozilla built. We want to turn this into a record that is going to be accessible from foreign code, which in this case means Swift. Same thing happens for Kotlin as well. So this is how the bindings get automatically generated. We just have to tell it, I want to create bindings for this type here. And here's what the auto-generated Swift code looks like for this type. We have a public struct with the name that you would expect. We have all the properties. All the Rust types are translated to Swift, so like F64 becomes double. And we even have doc strings for everything. So like if we go back to the Rust code, you can see these like 3 slashes. These are all documentation comments. and you'll get those pop up in your IDE. And the cool thing here is that you get the same developer experience on the Swift side. It translates all the documentation strings over. So every time that you rebuild the core, this file gets regenerated. And from the Swift user's perspective, like they wouldn't know it's different at all, which is pretty cool. And if you're thinking, you just like pulled a fast one there, how does it know what's a string in Swift or what's a F64 or something like that? So the stuff we looked at so far is just like automatically bridged, just like kind of magically in Swift, you can use an NS string or some of these other like Objective-C APIs. And it's automatically going to convert between the two. You can call an NS string method on a string and vice versa. And Apple does that, they call it toll-free bridging, I think, for you. The Unify framework does the exact same thing with this automatically generated glue code. But what about more complex? Also, we can, I skipped one thing. It will also automatically, like it knows what an enum is, it knows what a struct is. And so any level of nesting with these primitive types like strings that it knows about, it can do automatically. It works for dates. Most kind of primitive types that you would expect, it'll just work for you. Custom types, though, that are a little bit more complicated, like let's look at a UUID. So in Swift, we have UUID in the standard library, and I think it's now in the Kotlin standard library as well. I think for a while you had to use the Java util UUID class. But point being, we have ways of thinking about UUIDs on both platforms already. So how do we do that and bridge these three different types from Rust? So first we have to tell Unify, the bridge layer, hey, we're going to make a custom type definition. The first argument says UUID is the Rust type. That could be a type that we defined, or it could come from a library. In this case, it came from a library, but you can define your own whatever you want as well. And then the second thing is how it gets represented. So you can tell it to represent it using anything that it already knows how to represent. So like a string or a number or something like that. I probably could have done this with like 128-bit integers in some clever way. But I didn't want to deal with figuring out how to make that work on iOS and Android. But yeah, anything that it knows how to bridge automatically, you can do. So we'll use strings because UUID is like everyone has the standard way of writing it out in hexadecimal with dashes in the middle. Then we have this custom type converter. It's a trait. It's basically like a protocol in Swift. So basically saying we're implementing this protocol, this interface, using the built-in type string, and then we just have to define two-way mappings. So the first one, all that it does is say, I have a string, how do I convert that to a UUID? And then vice versa, how do I convert a UUID into the underlying type, which is a string? And these methods can fail, by the way. You can see it's a result type. And I think Swift has result types now, although I think throwing an exception is probably a bit more normal, and similarly in Kotlin. But that's really ugly, because what this will end up doing is just throwing a type alias UUID in your code, which will not give you all the nice things of a UUID in Swift, and it will also be very confusing to your users who have now two types named UUID, one with a different casing probably. So what we can do is we can give it some, it's basically like template code, these two mustache braces or whatever, say insert the actual value here. So on iOS, we can construct the UUID from a string using the UUID string constructor. And then similarly, we can get it back into the string format by calling .uuid string property. And now we magically have UUIDs that are bridged across both iOS and Android and Rust. And I see we also have pizza. Should have done a pizza bridge example. Okay, enough about data models. How do we share code? Useful stuff. We can share code in pretty much the same way. We just need to add this unify attributes at the top. So in this case, we're defining something it's a struct in Rust, but it's going to be bridged just like a class in Swift, which is reference type. We say we want to export this implementation, and then we can define multiple constructors. We can define instance methods and so on, and it'll show up just like a native class in Swift. My favorite feature though is probably traits. So these are like protocols in Swift, and they define a set of methods that you need to implement. This one defines one for saying whether the user is off route or not. This is surprisingly not going to be the same for every kind of routing. If you are a pedestrian walking through Gangnam, your GPS is probably going to say at some point, oh, you're just like randomly 50 meters off now, and you don't necessarily want that to make the user recalculate their route. So this is something that's kind of dependent on the exact use case, and we're building an SDK for others to use. So they need to be able to set this behavior themselves. So this little with foreign thing at the top right is magic that translates this into a Swift protocol. And what's really cool is you can actually just implement this code in Swift. You can implement this protocol in Swift, and then you can pass that into your Rust core. So I can say, I have a route deviation detector. I want to pass this into my core, and it's going to do something with it. So when it gets a new location update, it's going to decide, is the user off route or not? You don't have to rely on code that we've shipped in the Rust core. You can actually write that in Swift yourself. Does that make sense? That's a pretty wild. That's a pretty wild thing. Anyone have any questions about that? Okay, cool. Yeah.
I have a lot of
Sometimes it's good. There is a certain location, there is a certain URL, there is information, there is URL. Sometimes the URL and it doesn't bring the data. For example, there is a restaurant location, certain location, there is a restaurant URL, included restaurant photo. But sometimes the URL doesn't tracking the photo is green, and the Swift program is show the location of restaurant photo. That is doesn't miss that the URL has a location information green.
I'm not quite sure I understand the question, sorry.
Oh, okay. As I know,
Yeah.
there is for example, there is a restaurant list.
Mm-hmm.
Every single restaurant there is information,
Mm-hmm.
and the cuisine,
Yeah.
and the photograph,
Yeah.
whatever there is information,
Mhm.
and the review as well. How the customers present it as a
Yeah.
rating, and there is URL that is all information there is.
Mhm.
But sometimes there is that doesn't everything is clean. Sometimes missing some information. Location. That is that the missing rate is reduced if there was the programming.
It could be. So you're talking about missing data in someone's database of restaurants, right?
Yes, location there is
Mm-hmm.
information. It's kind of
Yeah. Yeah. So that would be something that's kind of outside the scope of the technical stuff that we're doing here. Like that would be a problem with the restaurant API or something like that.
That is maybe there is a reduce of that missing rate.
Maybe. I don't think a programming language is necessarily going to make a difference on that, though. Yeah.
Operating is maybe operating is not possible because mostly the all around.
Yeah.
Location.
Yeah.
Otherwise, the operating because
so off route, that means when the user is supposed to be walking down the street and then they take a detour onto a side street. The navigation is expecting them to keep walking straight, but they have gone some other way, and then the app needs to recalculate where the user is going. Yeah. So this lets you define this logic yourself. Yeah. Yeah. Okay. I'm going to skip that review section. right now. Let's talk about what time do we have till? Just keep going. Okay. Okay. Build tooling. So how do you actually build something like this? Let's. So your questions earlier about how do you actually how do you do this? What are different layers? So packaging is actually the hardest part of this. It's not writing the code. It's the packaging side of things. For iOS, we just literally have a ZSH script that runs the process because Xcode and their build system is not very easy to bend to your will and do custom actions with. I'm aware of some projects that use like Bazel or other complicated build systems like that. They're complicated for a reason, and it wasn't something that we had time to really look into. I'm going to show some. I'm going to kind of walk through some things, but don't feel like you need to stop and take a picture of everything. This is all available in a public GitHub repository that you can actually use as a template. Just fork and create a new one, and I'll have a link to that at the end. But what are the actual steps? So cargo build. This is the portability thing that's amazing. All that you do that's different from normal is you just add this target at the end. So we've got 3 targets here: the iOS device, and then 2 simulator targets, one for x86 and one for ARM. And then at the end of that, you'll just have 3 libraries sitting in your directory. These are completely good to go libraries. Then we need to, how do we generate all that Swift code? When I showed you, I wrote a Rust data model, like a structure in enum, and then it translates into Swift. How does that happen? That is via a tool called Unify Bindgen Swift. You just give it the path to your code and then the output directory, and all the rest of this is just in the service of staging things up for the XC framework creation, which we'll get to in a second. Universal binaries. We also need to create a universal binary as part of the process, which is one of the things that tripped me up for a while. So the stuff that Cargo Build spits out are correct architecture-dependent libraries, but the way Apple designed XC framework, which is their way of sharing binary frameworks, it only allows one library for platform, and Apple one library file per platform. Apple defines a platform as iOS device, iOS simulator. But while all of our iOS devices are ARM-based, we've still got these Intel Macs. So there's also an x86 simulator. And so what we got to do is we have to go out of our way and use this tool called LiPo to kind of fuse the 2 simulator binary libraries into one. And there's just architecture-specific slices for ARMS and x86. Then we can finally build the XC framework. Ignore the section at the bottom for now. We're going to come back to that in a second. The only thing that's important is this one Xcode build. I should have just cut my slides better. It's called Xcode build, create XC framework, and we give the paths to the 2 libraries, 1 per platform, and then we tell it where we want to dump the output. It looks like a lot, but there's really not a whole lot going on there. Our package.swift file, we're going to package this up in a Swift package, and we can just go push it on GitHub or whatever. Unfortunately, for local development, our setup has to be a bit complicated. Swift Package Manager doesn't have a good way to switch between local and remote dependencies. Particularly with binary targets, this is really annoying. I think you can just switch strings or something. For a lot of build systems, you can just switch strings. For Swift Package Manager, you have to actually add the second, or you have to add this 3rd argument at the end for the remote one. Because what we're doing with a binary target is we're saying just download this code and YOLO. That's a really huge supply chain attack vector if you have someone who gets access to your GitHub account and swaps out release artifacts or something. So you have to include an explicit release checksum whenever you're distributing a package.swift file with a binary dependency that is not on the local machine. So I haven't found a better way to do this yet. Probably someone has, but for now, I've just got to use local framework equals true or false bool toggle at the top, and you have to switch this for local development. Your users don't have this problem. This is only for you as the framework author. And now we can go back to this little bit at the bottom that I told you to ignore. So when we're actually cutting a release, this XC framework is just a directory tree with a bunch of files in it according to a particular structure. So you have your libraries organized into a particular nesting of directories, and you have like a module map file or something like that. So we need to zip that up, generate the checksum that you are going to put in your package.swift, which we just looked at. That's how you generate that checksum. There's a Swift package compute checksum tool. And then the other stuff at the bottom is just using sed to modify the file so that the version number changes the release tag. And we can put this all in our CI/CD release pipeline. This is unfortunately a bit fun because you have to know the checksum and put that in the file, but the time at which the zip archive is created determines the checksum because there's this metadata in there. So if you're doing your release builds in a GitHub Actions pipeline, you have to run the thing that generates the XC framework, edit your package.swift file, upload the release artifact to GitHub Actions, and then you have to do another automated commit to update your package.swift file with the new checksum. Otherwise, it's going to be incorrect, and people won't be able to download your package. So that's a little bit annoying, and yeah, fun stuff. That's also solved in our GitHub template. So wrapping things up. Write once, run anywhere to me isn't just about having a working app that's kind of like minimally okay and does all the stuff and just has a single code base. It's about carefully designing your things that you can reuse, like your core business models and data structures, and having those in a shared library that then you can share with other people, and then create a really nice native like Swift UI experience on top of that. Or put it on the web. Our navigation SDK actually works in a web browser with PWA. It uses the JavaScript location support and WASM runtime and stuff that's built into every device. Pretty cool. Stay in touch. There's QR code for my LinkedIn, email, Mastodon, and link to the Unify starter package. Cool.
Any questions?
Would you please update the run? And I'm curious what is supposed to be about. Would you update that run and what?
Sorry, update the what?
Such as emoji, what kind of graphics about? I'm curious. Would you update that run your application?
Can you show maybe on the project
file
structure how this looks like when you build and run the Rust?
Such as my Twitter emoji, things like that. I guess so, but I'm not sure. What's your
like building the Xcode project, or
your project?
Yeah.
You wanted to show the demos?
Yeah, sure.
I'm curious.
Yeah. Bring this over. I apologize. I am kind of blind here. Let's see. Does this work? Yeah, it's running. Yeah. I'm connected to the network, I think, so hopefully this works. Okay, good. Cool. There we go. Okay, so what is going to happen is, so this is a Swift UI app, like you can see the Swift UI layout in the background. And what the app is going to do is fetch a route from our API. The device's location, we're not using the Apple simulated routes. What's that under? we are not using the like City Drive or something like that. We are manually we're using the simulation framework that's built into the Rust core in order to do this. The map, all the elements in the map are driven with SwiftUI, including this little dot which shows the user's instantaneous location, and you'll see a bit of smoothing and stuff going on. So when I click Start Navigation, if all goes well, it will make a request to the server. It will parse the route. That's all in the Rust code, and then only using URL session for the transport. And then it will generate a series of location updates along the route. And each time, the core will generate a new state of this is the state of our navigation session. And then SwiftUI will pick up on those changes because it's just calling and then storing the result. So it'll use the like observable object pattern to pick all that up, and then things will happen.
5 keys, then turn right, then turn left. Turn
so
left,
it's triggering
in 40 meters. Turn
that down a little bit. Yeah. So it's triggering text-to-speech updates and stuff. Like that's not Rust. That's just we've defined interfaces. So it'll trigger everything on iOS using the AV speech synthesizer.
In
so
100
yeah,
meters,
it's
turn left
it's
onto
getting different
Mariani
attributes
Avenue.
like the road's name and updating that. It's getting the speed limit information from our database, and yeah, you can see as you
Turn
move along
left
the route,
onto Mariani
the distance
Avenue.
at the top changes, and so on. So yeah,
This is the dream.
that's a real app.
Green lights all the time.
Yeah, exactly.
Turn on Mariani Avenue.
Yeah, traffic not to scale.
Turn left to stay on Mariani Avenue.
Yeah, we got
Turn left
other
onto
fun
the
like
cycleway.
SwiftUI things
Turn
like
left onto
this.
the
Yeah,
cycleway.
yeah. So it's bicycle direction, so it's a little bit weird and
Continue
windy.
on Merritt Drive.
Yeah. That's that. Yeah.
Any other questions?
I'm sorry.
Yeah. I'll talk to you later.
Thank you for your presentation.
Yeah.
So I was a little late, and maybe you already explained it, but I would appreciate it if you explain the reason behind choosing Rust, considering the complexity of development.
Yeah.
In what cases it's better to use Rust over native development or like student?
Yeah. So why Rust versus native development? Let's take that one first. Basically, it's that your dev team resources are not enough to have a native iOS developer, a native Android developer, maybe multiple. So that's the main reason. The second, though, would be like you're defining the same kinds of like data models and stuff everywhere anyways. Like it kind of makes sense to just not repeat yourself. If you know that you're going to be building for multiple platforms, then you might as well do that from the beginning. So that's my take on that. Why Rust versus other languages? I talked about C++ is the one that the industry normally uses for that. The main reasons I prefer not C++ are memory safety. You can just get a random seg fault and your app blows up. It's not very easy to write correct C++ compared to correct Rust. Rust, the language, it's very much from the functional programming tradition where we have these patterns like immutable state. We have rich typing with enumerations, which we also have in Swift. And so it's actually, there's not that much of a gap between Rust and Swift. They both come from very similar roots. And so a Swift developer learning Rust is not that hard. The main thing is that you have to be very pedantic with Rust's memory borrow checker. But yeah, after you get past that though, then your code will run basically forever.
And in what cases it's better to use Rust over just like your team?
Yeah, that's the main one. If you either need a shared core or you don't. In the case of a small project, you probably don't. So I would just make two native apps in that case. Yeah.
The app looks very amazing to me. Is that a production level application or test application?
This is a test application, although if you want some production level applications, there's one called Hudhud that's just launching now they're in Saudi Arabia. I'm not sure if they have anything that like works in Korea or not. They're using their own proprietary data and stuff, but they're using this framework. I'm not the only. I didn't write this whole thing myself. There's a bunch of other developers that have contributed to this. The guys from Hudhud. There's a company called Rollista based in the U.S. Their niche is the like classic car weekend drive kind of events, and so they had an app that was written using another open source navigation SDK that is not really like all modern and up with like Swift UI, Jetpack Compose, things like that. I guess one thing I didn't really talk about here is all of the UI is composable, so you can either take you can take parts of it or all of it or none of it. So like Hudhud, for example, they use their own UI. In fact, they're not even using Swift UI; they're just using the core of this. So yeah, I guess I would also add to my answer for you, if you're building a library that could be used by other people, you should definitely look at something like Rust for that.
And
Yeah.
my another question is, if it's going to be production level application, let's say,
Yeah.
what is it that it has that Apple or Google Maps doesn't have?
Oh, good question. It's mostly about flexibility of the navigation experience and the kinds of routes that you can generate. Flexibility of the navigation experience, like you can dream up whatever you want with this. The last time I was asked this question, I was on a podcast and I said, well, what if you just want to make a really minimal thing that's just like a compass and some lines for a bicyclist they're just like cruising around town and they want to get where they want to go, but it's not like I don't need Siri telling me every like 30 seconds like turn right here. It's like I'll get there anyways. And it turns out someone actually built an app that does just this. So things like that where you want to really customize the navigation experience. If you're say a logistics company, say you're Coupang and you want to have dispatch to your drivers, or say you're Uber, you want to dispatch to your drivers, you can do all that with a custom navigation experience, and you have the full control over all that. I think there was one other question in there from you. Did I answer all of that?
Yes, you answered all of that. Thank you very much.
Yeah. Oh, was that what can you do that Google and Apple can't? The other part of that was golf cart routing, among other things. With Google or Apple, you're just with Google, you can't even get driving directions in Korea for one. So yeah, I mean, there's all kinds of different transport modes, different regional restrictions and stuff, and so that would be one reason to use like us.
And maybe to also answer part of the question for the people that maybe didn't come a bit late and didn't see the intro, Ian and his company are responsible for building the library, the SDK that other apps can use to leverage maps. So that's why maybe when you ask, oh, is it the production or test one? He's not responsible for that.
Yes.
Yes. So just to be clear.
Thank you, Florian. Yes. Missing context.
Yeah.
Yes.
Yeah, sorry about that.
No, it's fine. It's fine. Yeah.
Any other question?
Or kind of and first of all, thank you for your insight. A long time ago, I heard that the Android developer there is a big problem when we use NDK with Java. It's not easy for debugging. So I want to know the same question in this case. I want to hear your experience when you are debugging with the simulator and when you want to find out the inside code with Rust for this Swift UI application.
Really good question. Okay. Couple of things. One, this is not debugging, but what comes before debugging is you should have good logging. Logging does work very well. Debugging is in the sense I want to set a breakpoint in my Rust code, and when I push the navigation button in the Swift UI app, then it breaks there. That is not the best at this point. It is possible, but that takes a lot of setup. In the case, what I would say though is you should design the core in such a way that it's highly testable. So in our case, we have a crap load of everything from unit tests to integration tests to property tests, which are, for anyone who doesn't know what a property test is, you're saying, I want to have like random inputs X and Y, and they're both 64-bit floating point numbers, and X is going to be between like minus 180 and 180, and then you can generate like random coordinates like this. And then I want to see if there's any kind of like crashes or unexpected behavior or something like that from your library functions. So normally, I guess I'd say I practice like defensive programming in that sense and try and make sure that there isn't a problem where I need to actually step into a debugger. But there are ways to do that if you really need to. Yeah.
Any other question?
Sorry. Which business model did you find for this type of service, like setting the package, or is it an API key or something else?
Yeah, really good question. So yeah, this is an open source SDK. Anyone can use it, but you need something to generate the routes for you. Or you need something to do the address to coordinate conversion. And so our company, Stadium Apps, that's what we do. We're an API provider for all of this.
What was the other question? Nothing?
No, I'll just.
Maybe two last questions.
Yeah.
Is when did you make that decision to use Rust? I mean, from the moment you started the company to the moment you decided to use Rust to maybe solve the problem you were having? Like,
Yeah.
How did it go? How long did it take?
Really good questions. So we started the company in 2017. This is only like a year and change old product. But we use Rust internally for a lot of things. We use Rust for a lot of our backend services. We made that decision when we started hitting scaling limits with Node and Python. I can talk about that for a very long time, but basically Rust code ended up being a lot harder to write initially because it is very pedantic about you doing things correctly. Like your code may be fine, but the Rust borrow checker is like, no, you have to actually like mathematically prove to me that there's no data race going on here. If you've used the new Swift 6 concurrency stuff, it's actually not that different of an experience. The Swift 6 concurrency strict checks are starting to bring that kind of level of rigor to Swift. So it took us, I would say it took me several months to get comfortable writing Rust at like a good level of output in terms of like speed. It took me several months, which is a long time compared to most other programming languages. But yeah, we've found since 2018 that it's definitely been worth it to write stuff that you want to maintain for a long time in Rust.
On that, did Swift and C++ interrupt made you challenge this decision?
Oh yeah, the new Swift C++ interop is really cool. But one, that's like brand new, and two, there are some people who want to go and write new libraries and maintain them in C++, and there are some people who will go and contribute to an open source C++ project, but those people are relatively few in number compared to the people who will get excited about contributing to an open source Rust project. So there's a couple of things when you're dealing with a public project versus a private one, is you need to attract contributors in order for you to not do all the work. This would only be a third of what it is if I had to do all the work to build this from scratch. So that's definitely one factor. And then as the maintainer of a project, Rust is harder to write initially, but once you do like a quick code review and be like, does it look like this is doing what it is supposed to be doing? There's usually very few edge cases that you have to worry about. So that makes the effort to review a PR, to onboard a new core contributor, all these kinds of things, a whole lot less. So you actually end up saving time in a lot of ways.
And last one, because I everyone is getting hungry. Is let's say you got a new feature to build. I'm always curious about, and that might be one of the most difficult tasks, is except naming things is always about what goes to the core, what goes to this library. So what's your when you get a new feature, what's your thought process to say, okay, that should go to the core, that should go to the client libraries and so on.
Yeah. With iOS, Apple actually makes a lot of the decisions pretty easy. Well, for starters, if it's something like UI related, unless it's something like string generation or something like that, it probably belongs in your Swift project. Like even that stuff, like all of those, like when it was showing the bar at the top saying how many meters are left and stuff, like you can switch your phone language to Arabic and it'll just work because there's MK distance formatter. So like if there's already a good library that has support for something on your device, like you should probably use that unless there's a really good one that you're really confident in Rust. Like Rust is not going to know about your like your device locale settings, whereas both iOS and Android have good frameworks for dealing with this. That's kind of where or if it's like networking related or has to have some specific device functionality, that definitely has to go in the doesn't have to, but usually I'd say that goes in the native side. On the core side, is this something that can reasonably be shared across projects? Is my kind of decision rule.
Isn't it very easy to think that everything can be shared across like TTP? So
yeah,
make this distinction between all.
Yeah, I think the string generation example is a good one because like generating a localized string for something, like I could go and do that in Rust, but like iOS already has such a good thing with MK distance formatter that even though there is the option to do that, I'm actually going to pick the Swift API for that.
Okay, thank you very much.
The Rust language is a bright future because I
Yeah.
have no idea why, but
Yeah.
a few days ago I went to bookstore Kyobo branch, and I searched the Rust language. There is a book,
Yeah.
but there is all out of sight, sold out.
Wow.
That's why I guess might be a certain reason, but I have no idea what exactly is. I cannot describe exactly, but there is a certain demand, I suppose. That's why the book is all sold out.
Yeah.
That's why I'm very curious at the time. But maybe probably something quite different between the Swift and the Rust language between two languages. Might be something.
Well, Swift is a great language too, by the way.
Yeah,
like I said, they actually have a lot of shared ideas behind them. I think one of the reasons why Rust is very popular right now, though, is because it brings a lot of these ideas to every platform. You can write Rust code that runs on Windows, that runs in your web browser and WebAssembly module, or on your phone. And you can't do that with Swift today to the same extent. Yeah. Cool.
Right. Did everyone
Get
here
some pizza.
bought the book? That's why. No? Everyone did their homework before coming to the whole bunch. All right, big round of applause. Thank you very much.